What's going on YouTube? Welcome back. Today we are carrying over with this track, registered penetration tester, and today's machine will be GoodGames. Okay, so in this machine we're going to exploit an SQL injection vulnerability, server-side template injection, and at the end we're going to escalate privileges by through Dockers. So let's get started. As you can see, the machine is on. And let's go here. So the port that we're going to investigate, as you know guys, I'm skipping the nmap scan because it's easy, you can do it. The port that we'll be investigating in this machine will be port 80. So let's grab the IP address and go to port 80 or open the main page. As you can see, the main page is a gaming website and it has a lot of functionality. Posts, search area, socials, buttons in here. So there are a lot of functionality in here. This is expected from any real website. So it actually simulates a real website, but I'm going to make this short, guys. So basically, as you can see at the footer, we have goodgames.htp. Make sure to add this to the host's file. How to add it to the host file? Of course, you're not gonna ask me how to add it, guys, because it's easy. But as you can see, you can just type nano etc hosts, and you're going to edit this file and add this line. Add the IP address of the machine and goodgames.htp. Later on, you're going to add this entry as well. Okay, let's go back. So we have this one. If you go up, we have also links to blog and store, but none of this actually will lead us to somewhere. So the only thing that will lead us somewhere is the login and register functionality. So I'm gonna log out, say log out, and in here what you can do, you can click on the button here. You have an option to sign in and to sign up. So we're going to sign up. Any information is anything you enter here works. So nickname, test, and you choose a password. Sign up with the information and then log in. I'm gonna log in directly because I have an account created. So test 1 2 3, sign in, and we are internal server error. Something went wrong. Let's go back. You will have to register again, I guess. Anyway, test 1 2 3, test 1 2 3. Okay, now we sign in, and once you sign in, as you can see, it automatically redirects you to your profile page. Which again, there is nothing to do in the profile page. Waiting for the profile page to open. Hopefully it's not going to take forever. Okay, so this is the profile page. As you can see, we can see the information of the user, test, the email, and the date joined. And here we can change the password. Scrolling down and nothing else. And that's the username we chose. So what to do from here? As I told you guys, we're going to intercept the request sent to the server while we sign in. We want to see if there is an SQL injection vulnerability, because there is nothing else on the site. Even if you run directory search, you're going to discover the blog and the store page. So if you run directory search, the links that are already here will be returned in the output. So again, with directory search, there is nothing that would lead somewhere. So we go back here. So the only thing left, I know we are able to log in, but we want to log in as an admin. So the only way to do that is to test if the site is vulnerable for SQL injection vulnerability before we try to brute force using a dictionary attack or using a wordless attack. So let's sign out. So we sign out and we go back to signing in, enter the information, change to purp suite, and here we turn on the intercept, sign in. So this is the request sent in here. So again, we want to test if this site is vulnerable to SQL injection attack. Normally we would try the injection in the email or the password field. So we're going to start with the email field. We're going to replace the current email address with one of the SQL payloads. So let me type here SQL and locate the login payloads. So I have a couple payloads here. We can try this one first, and we don't need the semicolon. Let me tell you why. Because this website is based on Python. So how do we know that it's based on Python? That's a valid question. I'm going to tell you guys why, but let me first try the SQL injection payload. Again, don't copy the semicolon because Python automatically adds semicolon to the SQL queries. So we're going to copy only this. We're going to send this to the repeater, highlight send, and we have successful login. If you scroll down, you can see welcome admin test. So it means that we logged into the admin. Let's go back and forward this request, and let's now check out the page. Alright, so here, let me show you guys why it's based on Python. If you scan with nmap again, you're gonna see what I mean. Let's leave this running for a while. Let's go back. As you can see, welcome admin. So right now we have successfully logged into the admin profile. Okay, now if this was a CMS, or if this was some sort of dashboard where we can upload files, we would have uploaded some reversal, but there is no option here to upload files. So the next step is to take advantage of the fact that the site is vulnerable to SQL injection and dump the full contents of the database. How we're going to do that? We're going to go back to the login. Yeah, sign out. And again, we're going to say login again with the information we have got. Turn back to intercept. Sign in. We're going to send this to the repeater. All right. So we know that the email field is the email that's vulnerable to SQL injection. So this is where the playground will be. We're going to insert union select SQL payloads to be able to find out the schema name, database name, tables, columns, and therefore we dump the sensitive information. Let's go back to here and find what union payloads we can apply. By the way, you can find the file here, and if you are a member of the channel membership. Let's see some union select payloads. Okay, these ones are good. They look good. So we want first to find out how many columns in there. So let's take this one. Let's check first. Okay, first we want to find out how many columns are there. So if we go back to the main payload that worked when we logged in as an admin, let's take the main payload here. So this is the main payload. All right, put it here. And then we need the union payload. Union. These ones looks promising. Let's try with union. Too many data here on SQL. I would like to try, what the hell, why is this happening? Okay, let's scroll up. Okay, so let's try these first. Okay, so, okay, let's try this one. All right, so we have 1, 2, 3. If we get a successful login, it means we have 3 columns. Send. No successful login, as you can see. It means we don't have 3 columns. Let's try with 4. And we get a successful login. It means we have 4 columns. If you scroll down, we can see it says welcome 4. So we have 4 columns, and the 4th column is the vulnerable one. So we can change this with database to find more information. If you scroll down here, we can see the main database name. And now it's a roller coaster. After we find database name, we extract all the database names. Basically, we're gonna need to select. We're gonna need to use the group concat to find the schema name. So we're gonna take this payload all the way here. Okay, send. Successful login. Scrolling down. As you can see, we have information, schema, and we have main. Now, the next is to find out the tables. So we scroll down. This payload is useful for finding the tables. So we're going to highlight all of this up until the equal sign. And say here the main database. So we want to extract the columns from the main database, not information schema. Send. Problems started. Doesn't work. Thinks because of the space. It didn't work again. Group concat table name from information schema dot tables where table schema equal main. This should work. Let me go back. See why this is not working. Let's use a space here, maybe. Again, it did not work. Select group concat table name from information schema dot tables where table schema equal main. Let me go back here to the payload. Let's try this one more time. Got the closing parentheses, and now it worked. Scrolling down, we can see we have 3 columns: blog comments, and user. We are interested in displaying the fields in the user column. So we're going to extract these information. So highlight this. Table name equal user, not users. Send. Successful login. Scrolling down, we have these columns. Where are they? We have ID, email, password, and name. We're going to extract these information. So we have 2 options, this one or this one. The one that worked, guys, wait. So we have this one, extracting specific data from the column. This is first. And we have this. And we have this, but basically these are the same, I guess. So let me remove this one. We're going to use this one. Copy. So from users, it's gonna see from user, ID, name, password. So ID. Okay, that is okay. Send. Login success. So scrolling down, guys, we have, as you can see, the ID, the name, and the password. We are interested in the admin, so we're going to take this hash. Probably it is an MD5 hash. So what I did, I used John the Ripper. I stored the hash in a file called hash. I used this command with John the Ripper to crack the hash.
I use the format --format switch equal row MD5, and the password is super administrator. Now that's the password of the user admin. So what's the next step? Now the next step is, let's go back. Let's turn this off. We don't need this anymore. We need to log in back to the admin page. So we're going back to the SQL payload here. We're going to insert it in the email field because we want to get back to the admin profile. We're going to send. So as you can see on the admin profile, there is a button here. This button, we didn't see it when we first logged into the test profile. It means this button has something. So if you click on that, we are presented with this page. Now this page, if it wasn't added to the host file, it's not gonna open. It wouldn't open. So basically, make sure to add this host name to your host file. Okay, as I showed you guys earlier here. Okay, going back here. Now this is a dashboard again with a lot of functionality. So instead of just battling with all of that to find out what's the weakness, let's start simple. So let's first turn off the proxy, go to admin page, my profile. So we would like to see if we have some option here, some way to manipulate the input fields. Now remember that this website is based on Python, and you can take a hint. You can consider that the word Flask as a hint, right? But let's go back to the nmap scan I issued earlier. As you can see, the nmap scan showing that there is one open port, okay, and the web server is based on Python 3.9.2. That's how I found out it's Python. Okay, go back here. Now, whenever we have a web server that's powered using Python, and we have an input fields, it means we are before server-side template injection vulnerability. Of course, we want to attempt. It doesn't mean that there is a vulnerability, but that's the first thing that comes to mind when we see a web server based on Python. We want to test if it is vulnerable to SSTI. So let's pick up the payloads for SSTI, server side. Let's see the payloads here. One common payload is this one. So we're going to take this one. If it evaluates to 49, it means the subsite is vulnerable. Now, this payload can be attempted or tried in the URL or in the input fields. Here we have the input fields. Let's try it in the full name section. Input any information here like the birthday. The number can be anything. Update the admin information. As you can see, the full name has changed to 49. It means the full name input box executed the payload, which means the website is vulnerable to server-side template injection. Next step now is to grab a reverse shell. So let's see the reverse shell here. We have this one. This payload here is a Python payload SSTI to grab the ID of the user. We have two options. Let's try this one first. We input this in the vulnerable field. This should evaluate to the current ID of the user. Save all. As you can see, it is root. Okay, now it's time to grab a reverse shell. Back. Okay, so exit, exit, exit. Alright, reverse shell now. That's one option, but this is long. Last option is to bypass the filters. That's another option as well, but it grabs the shell from my attacking machine, and that's an easier option here. Let's take this one. No, this one. I need to close this one here. NC-LVP 4545. Back. This one should be, yeah, like this. So let's see now. And we have a shell. So the next step now is to, as I told you guys, the first thing we need to do is to stabilize the shell. So script dev null -c bash. Okay, Control Z, and then the next step is to stabilize the shell. Let's see here. Oh, come on. Okay, let's go back. I hope I remember the command. So it's STI. Yeah, it's here. Okay, so now we have a shell. As you can see, the ID is root, which is kind of weird. If we try to cd to root, let's... Okay, so the first thing to note, guys, is we are under root here, but it doesn't seem root because there is no flag here. Looks like we are under Docker profile. So how do you know that we are under Docker profile? The first sign is there is Docker environment or .docker environment file. So if you cd to home, cd Augustus. Okay, so we have these files, bash. This one I created. I'm going to tell you guys how to create this. And we have the user profile. So this is the user flag. It's all right. Let's cd to the main root file system, ls-la. As you can see, we have Docker environment file, which means we landed on a Docker environment here. So we want to escape the Docker environment. Let's first find out the main interface IP address. So it is 172.19.02. So that's the main interface IP address. Yeah. So the next step is we want to find out what is the actual IP address for the Docker. Before doing that, let's go back to the home directory. cd Augustus. Take a look at the permissions here. The permissions show user ID instead of names. This means that this directory, the home directory of Augustus, has been mounted from the main host to the Docker. So whatever we create here under this directory, it will be reflected on the same directory in the host, on the host end. Likewise, if you create later when we get access to the main host or when you escape the Docker, if you create file under this directory from the host end, it will be reflected as well here on the Docker end, because this directory home Augustus is a mount or has been mounted from the main host. That's how Docker works basically. So we can actually confirm this if we type mount grep Augustus. Indeed, as you can see, home Augustus has been mounted from the main host machine. Alright, so the next step is to find out the IP address, the main IP address that's assigned to Docker. To do that, we need to do some sort of ping. We want to ping the network. So we have many possibilities. If you look at the IP address here, again, as you can see, it's class C IP address. So we want to do, we will want to ping all the IP addresses, right, on this net mask. So it means we have around 254 IP addresses. To do that, we're going to use for loops. For I in, and here is 1, 2, 5, 4. Do, and then we perform the command. So the command will be ping -c 172.19.0, and as you can see, we can replace the 2 with the I because it's the host portion. Okay, and then we're going to say grep. So what we want to do, we want to see only the live hosts. So live hosts reply with bytes from. You see the bytes from statement from live host. So we're gonna grep this bytes from. Okay, now another thing to do is to exclude all replies that contain the word unreachable. We are not interested in these replies because they indicate non-live host or hosts that are non-existent, unreachable. Okay, where is the end? Yeah, and then we're gonna say done. Good, we have a problem in the command. Let's go back. I'm creating a new node file here. It's called dockers. I'm going to put all of the nodes on Docker penetration testing. It's still under development, guys. So let me see if I have this command here. Yeah, there it is. But I'm going to need to edit the IP address. It's going to be 172.19.0. Let's copy that. Easier than write this manually, because we are on an unstable shell. We don't want anything to break. Okay, we have two hosts live, 2 and 1. So 2, we already have the interface, the IP of the interface. So we're left with the one that ends with 1, which means this is the Docker IP address. Next thing, we want to scan this Docker. What are the open ports in there? So also need a for loop because we are scanning all the ports. Also, we need to replace the IP address here. It's going to be 1. For loops are very common in bash scripting to automate and expedite the tasks. So we have 2 ports, 22 and 80. We already have a password here. So let's try to log in to the SSH. So SSH Augustus, right? Okay. And this is the IP address. And this is the password. Indeed, we are logged in now to Austos. So pwd, we're under the home directory. Okay, so as you can see, it's exact same copy that we saw earlier in the Docker. So now we escape the Docker. So what's the next step? Also, if you look, guys, if you look at the process list, you will confirm your suspicions that Docker is running on the machine, as you can see here. All right, so what's the next step? Now, as you can see here, guys, previously I created a file called bash. So what I did, I copied bash, bin bash, from where? From the main host. I copied bash here, right, to the home directory of Austos, as you can see here. So what I did, I wanted to see if this file actually shows up in the Docker. So if I exit here now again, and now I am under the Docker, I'm back to Docker here. So ls, as you can see, I see the file here. This is the file. All right, so if you go back here, guys, as you can see on the host end, all of the permissions are root. Let's do a simple experiment. Let's go back to the host. Password not correct. Yeah, I know. Okay, pwd. Okay, so let's touch a file, create a file, test, right? So on the host end, this is the file, and these are the permissions. Let's go back now to the Docker container, ls-la, and we see the same file here, test. Okay, so as you can see, the changes are replicated from the host to the Docker and vice versa. Now, what if we abuse this functionality? So we know that we copied the bash from the host on the host end to the directory or the home directory of Austos. What if we change the permissions and the owner of the bash binary here from the Docker end, and we execute it on the host end to land as root? So what I did, I changed the owner root bash. That's first. I assigned the sudo bit to bash. What? Okay. And as you can see now, bash has the sudo bit set and has root as the owner and the group. Let's go back to the host. So I have it here. If I now execute bash with -b to preserve the permissions I assigned from the Docker end, I should land in a new shell ID, and it is the root shell. cd root, and now you have the flag. So that was it, guys. I hope you enjoyed the experience, and I will see you later.